So for class 12, the first chapter is relation function. First, recall that from class 11, we have already studied about sets. Okay, so now there is a set A which is non-empty. We define Cartesian product of two sets of set A and set B is denoted by Cartesian product is denoted by A cross B, and it is defined by the ordered pairs AB such that A belongs to A, capital A, and small b belongs to capital B. That means this is the ordered pairs A comma B. One element, the first element is from set A and second element from set B. Similarly, B cross A is the set. This set contains the element B comma A such that B belongs to capital B and A small a belongs to capital A. In general, we have seen that A cross B is not equal to B cross A unless this A cross B equal to B cross A when A equal to B. Until this uh, okay. Furthermore, we have learned that what is relation. Relations is any subset. Relation R is any subset of A cross B. Then R is a relation on A cross B. Sorry, R is a subset of A cross B. Then R is a relation from A to B. R is a relation from A to B. Now, the classification of relations. So there are three types of relation. One, okay. From this is the class 12 is starting from here. So until now, y- you have learned this in class 11. So what is classification of relation? Suppose, okay. uh, Before classifying the relation, the classification of relations is only applicable for the same set, means A cross A or B cross B. We cannot define such relations like reflexive relation or transitive relation or symmetric relation. We cannot define these things on A cross B. That will be much complex. That would be very much complex idea. Okay, so we are defining the relations or classifying the relations on the set A cross A or B cross B. That is on the same set. So when we classify the relation, R is a relation from A to A. Sorry. So when we classify the relations, we take R is from A cross A cross A, or R is a subset of A cross A or B cross B, like that. Okay. So now I am classifying the relation. Suppose A set has three element A, B, C. Now we already know that the elements of A cross A is, what is the elements How many elements are there in A cross A? Tell me. Well, so tell me how much elements, how many elements are there in A cross A?
3 into 3, 9.
Yes,
9
nine
elements.
elements are there. Okay, and Prantika has also told 9 elements. So R is the subset of this A cross A. So now, how the elements of A cross A looks like this: A comma B. Okay, first we are writing A comma A. Okay, then A comma B, then A comma C, then B comma A, B comma B, next B comma C, C comma A, C comma B, C comma C. Now, okay, this is the elements of A cross A. There are 9 elements in A cross A. So R is a subset of A cross A. Now I am picking a relation like this: A comma A, B comma B, C comma C, and uh, and with this and with these three elements, I am also picking some element A comma B or C comma B, C comma B, and B comma C. Now these three elements A comma A, B comma B, and C comma C. These three elements are self. I mean, this A is also paired with A. This A is from the first set A, and this A is from also first set A. Because these two sets are equal, that means we can pair up the same elements from A, that is A comma A and B comma B and C comma C, because A B C are the elements of C. A element A B C are the elements of set A, so we can pair the same elements. Whenever this type of elements A comma A, B comma B, and C comma C, like self elements. So whenever these the kind of elements are in the relation R, that relation is called reflexive relation. Now, a relation is said to be reflexive I'm not I am not writing the definition of the reflexive relations or any relation, because that you will find in the textbook. I am just explaining those things to you. Okay. So a relation is said to be reflexive when for all x belongs to A, this type of order pair x comma x belongs to R. A relation R is said to be this is some kind of definition. Okay. So second point is, except those elements x comma x for all x belongs to set A, other order pairs may uh, belongs to R or may not belongs to R. So what I am trying to say that this a comma a, b comma b, and c comma c, except these type of elements, self element, any other elements can belong, may belong, or may not be belong. 3. If for any x belongs to a, x comma x does not belongs to r, then r is not a reflexive relation. These things are follows from the definition. Okay, I'm writing this thing. So for every x belongs to a, x comma x must be belongs to r in order to be r is a reflexive relation. So like this, if we take r to be this relation, suppose a comma a, c comma c, and then we are taking a comma b, b comma c comma a. This r is not a reflexive relation. This r is not a reflexive relation. This is not a reflexive relation. Why? Because b comma b does not belongs to r and b belongs to a. Okay, for b belongs to a, b comma b does not belongs to r. This is the reason r is not a reflexive relation. Okay, I hope you have understood. Yes or no?
Yes, sir.
I didn't understand. Reflexive relation.
Why? Which point you did not understand? Tell me which point. The among these 3 points, which you cannot understand. Tell me. Did you read these three points?
Yes.
So tell me, okay, which of these three options you cannot understand? You are unable to understand. Tell me which one.
Third.
Third.
Third
Okay.
point.
Okay. This is the example of the third point. What I am trying to say, if for any, for any means if there exists one x belongs to a such that x comma a does not belongs to r, then r will not be a reflexive relation. Because see, the a set was a comma b comma c. A set has 3 elements, and amongst them b was an element, but we have construct a relation r with the elements a comma a, c comma c, a b, b comma c, and c comma a. In order to be a reflexive relation, r must have these 3 elements: a comma a, b comma b, and c comma c. And the second point is saying r, this reflexive relation r, except these x comma x elements, r may have other elements or may not have other elements. So except these 3 elements, r may have element or may not have. So this is the reflexive relation. To be precise, this is the reflexive relation. And I'm taking this as r1, this is r2, this is a comma a, this is b comma b, This is C comma C. For explaining the second point, I am taking another elements A comma B, B comma A, C comma B. These three elements. These extra three elements. So this is also a reflexive relation. This is the smallest reflexive relation where for all x belongs to A, I mean for all the elements of A, the self joint ordered pair will be in R. And R2, in addition of these three elements, other three elements also there. But this R3 is not a reflexive relation because we can omit any of the three elements. I am omitting the C comma C. So this is B comma B, and then I am taking A comma B or B comma A or C comma B. So uh, removed. We have removed this C comma C in R3. That is why this is not a reflexive relation, or something like this. This is also not a reflexive relation. A comma B, A comma A, and B comma B. This is also not a reflexive relation because C comma C is not in R3, as C is a part of the element, as C is as C is an element of set A, but C comma C is not an element of R3 or R4. That is why R3 and R4 is not a reflexive relation. Now, did you understand?
Yes, sir.
Yes.
Number two, second type of relation is symmetric relation. This relation function is the basics of higher mathematics. Okay, uh, in whole class 11 and 12, these two chapter, relation and function, I mean uh, those part, those things which are some logical things in function that are not included in class 11 12, but this relation function is something, or somehow requires some logical reasoning to do, and this is the basics of higher mathematics. Otherwise class 11 12 is based on a principle that how to do, how to do something. I mean the whole calculus is how to do calculation, how to get a result, how to get a desired result, desired this this I mean how to manipulate this integration, or how to differentiate this thing with some manipulation of algebraic manipulation or something. But this relation function is somehow logical, will enhance your logical thinking or analytical thinking. Okay, so what is symmetric relation? Symmetric relation is like this. I'm not writing the definition, I'm writing the main thing. So is a set ABC. Now I am defining a relation which is a subset of A cross A. This is A comma A, A comma B, and B comma A. This is R1. This is R2. A comma A, B comma B, C comma C, A comma B, B comma A. So in the definition of symmetric relation, it is written that if A comma B belongs to R, then B comma A should also belongs to R. If this happen, then R is a symmetric relation. It is not necessary that A and B should be different element. Okay, so first of all, it is not necessary that A should not be equal to B. It may happen that A is equal to B. So according to this definition, tell me whether R1 is symmetric or not.
So what did you say? That if part. If AB belongs to R.
Suppose A is a set ABC, and now we are taking a relation R such that if A comma B belongs to R, then B comma A belongs to R. In order to be R is a symmetric relation. Okay. Then, okay. R is said to be a symmetric relation if A comma B belongs to R implies B comma A belongs to R. You know this sign?
Yes.
Yeah, you have learned that mathematical reasoning, right? And you know the imply sign.
Yes, sir.
Okay. Patiti, you know that?
Yes.
Okay. So now this R is said to be a symmetric relation if A comma B belongs to R implies B comma A belongs to R. Okay. Some note that it is not necessary that A should not be equal to B. It is not necessary that A and B should be two unequal element. Okay. Now tell me, R1 is
Okay.
R1 a symmetric relation?
Yes.
Why? Because it is
Because it,
because it is from the definition that A comma B belongs to R should be B comma A belongs to R. This is
yes, sir.
the simplest form of the symmetric relation. Tell me, R3 a reflexive relation or not? Sorry, symmetric relation or not?
Yes, it also belongs A, B, and B.
And what about the other three terms? This thing. Because this is the elements of a reflexive relation. So tell me, will these three elements? Will these three elements make some problem to R to be a symmetric relation or not?
Mm, no.
Why? Why they will not make any problem?
Because A comma B and B comma is already there.
Yes, sir.
A comma B and B comma A is already there. I am not asking about this thing because these two are following from the definition A comma B is and B comma A from this.
So it satisfies the condition. So
Oh, okay. That these two satisfies this condition. But what about these three elements? I mean, is these three violating the condition?
No.
No.
No, these three are not violating the condition. But I have already written that this point, that it is not necessary that A and B should be unequal. A and B may be equal, and for these three elements, A and B are both equal. A comma A and B comma B and C comma C. Okay, am I clear?
Yes, sir.
I have already told that A, it is not necessary that A unequal to B. I mean, A should be different from B. A may be equal to A. So that is why these three elements are not causing any problem. So R3, is this relation asymmetric one?
No.
Why? What is the
Sir,
problem?
because it's not satisfying the condition needed to be the symmetric relation.
How it is not satisfying? Tell me. Explain to me.
Sir, it is a reflex relation.
So what? It is a reflexive relation. I know that. But why it is not a symmetric relation? Can you tell? I mean, can you mention some A comma B for that A comma B comma A is does not belongs B comma A does not belongs to R? Can you find some A comma B? Remember
No.
how we proved that phi is a subset of A. Remember those things? How we have proved that phi is a subset of any set A, any set, because phi does not contains any x does not belongs to phi. I mean, there exist any x, there does not exist any x such that x belongs to phi. So we are not getting any x or element to show that x does not belongs to A in order to be phi be a subset of A. Here is also the same. We are not getting any AB such that A comma B belongs to R. That should not implies that B comma A belongs to R. Or rather, we can say here A is equal to B. A comma B belongs to R should implies B comma A belongs to R. I have already told that A should not be different from B. It may happen that A is equal to B. That is why A equal to B. Here A equal to B. Here B equal to A, and here C is all are equal. Those order pairs, the two elements of order pairs are equal here. So this is a symmetric relation.
Okay.
Whenever there is two different element A comma B, A and B, then we will check B comma A is belongs to R.
Sir, a
Otherwise,
set can be both reflex and symmetric.
what?
A set can be both reflex and symmetric.
A set A set cannot be reflexive or symmetric. A relation can be reflective or symmetric.
Yes, a relation.
A relation can be
It can be both.
both. Yes, uh, I have I never told that a relation cannot be reflexive symmetric simultaneous. I never told that. I am just giving the definition, and from the definition, this reflexive relation is also a symmetric relation. And eventually, we will see that the reflexive relation is the smallest equivalence relation.
Okay.
Before going to the equivalence relation, we will introduce the transitive relation and then the equivalence relation. But before that, I have already told because you have asked that R is a reflexive and symmetric relation both. Okay, so and there is another relation that is not mentioned in the syllabus, that is antisymmetric. I will give all examples with the real real world examples, I mean with numbers or like that, and the operations. Antisymmetric relation is what? Antisymmetric relation is a comma b belongs to R and b comma a belongs to R should imply a equal to b. This is I mean something you- this is something okay. If is here, if a comma b belongs to R and b comma a belongs to R, that means if this is symmetric, then a should be equal to b. Okay, I'll not explain more about this. Now, number 3 is transitive relation. The most confusing relation is this transitive relation. So listen carefully. Okay, the definition is if a comma b belongs to R and b comma c belongs to R, then a comma c belongs to R, and then R is a transitive relation. Now read this and convince yourself. I will ask some question. Okay. Okay. Ex- I'm I'm explaining this definition. So what is this definition trying to say? That if we find A and B that is belongs to the relation R, then we will check again that whether B comma C is belongs to R or not. Then we will check that A comma C belongs to R or not. The checking part is this, and before that we have to check that A comma B and B comma C is belongs to R or not. Again, I will mention that here also A comma B comma C may not be different. A and B and C may not be different, may be equal element. I'm not again when we define the transitive relation, that is not mentioned that A and B and C will be three different elements. Okay, so the first point is A, B, C may be different elements, may be different element or may not. This is the first point. Next, second point is we will check whether A comma C belongs to R only when we get A, B, C such that A, B belongs to R and B, C belongs to R. If we failed to find AB belongs to R and BC belongs to R, then R will be transitive. From this, first example is the reflexive relation and symmetric relation, and this is also transitive relation. I am saying that because you cannot find any AB and BC such that AB BC belongs to R, then you have to check whether AC belongs to R or not. Praditi, did you understand? Praditi? Okay, so I have already told that R1 is a transitive relation. So prove me wrong if you can.
So can you explain the last point?
Sorry,
The last point, the second point.
are you uh, telling me to explain that?
Yes.
Okay, so uh, so the R1 example, taking the R1 example. So here, is there any A comma B or B comma C? Maybe these two are equal. I mean A comma B, here B is equal to A, no A comma B and B comma C, so that we will check A comma C is belongs to, I mean, R1. This is transitive relation. Okay, now I am taking another example. Suppose this is A comma B and B comma A. Okay, this was a symmetric relation, right? And this is R3. This is A comma B, B comma C, A comma C, A comma B, B comma A. Okay, now tell whether R2 is transitive or not.
No,
Why?
because there is no C, not 2.
So what? There is no C. So what? Uh, Maybe I have told that ABC may not be equal, may not be unequal. They could be equal. I mean A comma B and B comma C. Here C is equal to A. Take that C is equal to A because there is no restriction and B and C should be all different. So if we take C for this example, if we take C equal to A, so now can you tell whether this function is transitive or not? What did you tell me?
Yeah.
Yes.
You are saying that yes, this is a transitive relation. Hello, tell me, R2 is transitive or not?
So it's transitive.
Why?
So, because C is considered A, so it is satisfying the condition,
Okay,
and
yes.
is
It is satisfying that A comma B and B comma C belongs to R because we have taken that C is equal to A. But what was the last then statement? Then statement was A comma C belongs to R in order to be R to be a transitive relation. But whether A comma A belongs to R2, because we have taken C equal to A for by the definition A comma C is going to be A comma A. Okay, now I'm writing A comma B and B comma C. For this, B comma C is also B comma A. Now, to check A comma C belongs to R, we have to ultimately check A comma A belongs to R or not. We have to check this. But R2 does not belong, A comma A does not belongs to R2. So R2 is not a transitive relation. So did you notice whether why R2 is not a transitive relation?
Yes.
Prantika?
Yes.
Okay, now tell me about R3.
Transitive.
Okay, explain.
So because it has A comma B and B comma C, so
Okay, A comma B, B comma C, and A comma C is there.
A comma C.
Okay, so according to you, it is transitive. Pratiti, according to you, whether it is transitive or not?
Transitive.
So you have the same argument. A comma B and B comma C belongs to R, and A comma C also belongs to R. Right?
Yes.
So both of you did not check for this element, two element. Again, this is the R2. This was the R2. In order to be R3 a transitive relation, it must satisfy for all elements. These three elements satisfy the condition of a transitive relation. A comma B belongs to R, B comma C belongs to R, and hence also A comma C belongs to R. This will satisfy. But for this, the transitive relation condition is not satisfied because A comma B is there, B comma is there, B comma A is there, but A comma C, which is A comma A, does not belongs to R3. Again, this is not a transitive relation. So R2 and R3 not a transitive relation. Okay. Now,
Okay.
now R4. R4 is A comma B and C comma A. These two elements. Now tell me, R4 is whether R4 is transitive or not. Take some time. Sometime. There is no rush.
It's, so it's transitive
Why?
because it has A comma B and C comma A,
No.
and
Okay, okay. Yes, tell me.
there are no other elements.
So you cannot find any A comma B and B comma C such that you have to check A comma C is belongs to R, right? Right?
Yes.
Right? Okay,
Yes.
okay, okay. Now see this. If we write this, can you find A comma B and B comma C such that A comma C is belongs to R? I'm just reordering the elements.
No.
So R4 is not a transitive relation.
Okay.
Because here C comma A and A comma B, but C comma B does not belongs to R4, right? That is why R4 is not a transitive relation. R5. Okay, think about R5. I'm writing another element. Okay, for this, uh, for three element, this is enough examples. Now I have to introduce one more element. Now tell me whether R5 is transitive or not.
Transitive.
Who is saying? Explain why it is transitive. Why you have told? Tell me the reasoning. Why you have told this is transitive relation?
Because A comma B, B comma C and C comma A, this all belongs to R. So
Okay, you did not notice the definition. I have told that A comma B, B comma C, then A comma C belongs to R.
Sir, not transit.
It is not transitive because here it is C comma A, not A comma C is R in R5. And also there is one more thing. B comma C and C comma A belongs to R5, but this is B comma A does not belongs to R5. So this is not a transitive relation. Okay, got it, Putiti?
okay,
Now I am introducing another element. So taking A as a set of four alphabets A, B, C, D. Now I am defining a relation A comma B, C comma D. Acha. Then okay, these two. Now tell me, is this relation transitive? This is the application of the second note. Okay, let me see the second note. Yes, this is the application of second note. It cannot be done with three elements. It can be done with four elements. Tell me whether this is transitive or not. Again, read the second point. I will give this note. So should I open the second point? Okay, I am opening. Read it and then try to find whether those R1 is transitive or
Sir, it is transitive.
not. Okay. Do you agree, Padati? Aditi, what is your opinion?
Once, can you show the second point?
Yeah, sure. Prantika, think about why you have told that this is a transitive relation. After some time, I will ask you. After that, I will give some real life examples, that is using numbers or some other relations. So now tell me, Pratiti, is this relation transitive?
Yes, transitive.
Still confused. So tell me why you have told that it is transitive. You thought something and then tell me, na? Right? So what you have thought?
Because in A comma B and C comma D,
Yes,
there is no any common things between these two pairs.
yes. There is no common element, so that we we try to find A comma C belongs to R. There is no common element. Okay, this is the right argument. Or okay. So Prantika, tell me.
So yes, transitive.
Yes, you have already told that it is transitive, and you thought like this. There is no common element between
Yes,
these two elements. Okay, thank you. So right, there is no common element, so that we can check AC belongs to R. One. There is no common element B such that we have to check AC belongs to R. So this is a transitive relation. This is the point. Okay. Now real life example. Some examples. The best example is, suppose LB is the set of all straight lines on XY plane. Now I am defining a relation R, L1, L2, such that L1 is perpendicular to L1 and L2 belongs to L. Okay. Now tell me or check whether R is reflexive, symmetric, or transitive. And you also can check whether this is antisymmetric or not. This is not necessary, but it will develop more analytical thinking of you. Now I will not, so I will not check what you have written in exercise book. I will ask one by one. I mean, whether this is reflexive or not, why it is not reflexive, or why it is not symmetric, why it is not transitive. That I will ask that. Maybe you have to draw some pictures of two straight line in order to check those relations. Okay, now checking whether R is reflexive or not. Now, in order to check whether R is reflexive, we have to show that L1 is perpendicular to L1 itself. So, is this true? Whether L1 is perpendicular to L2, L1 itself? A straight line is perpendicular to itself. This is true or false?
False.
Okay, so this is a straight line. It is perpendicular to itself. This is false
No.
statement. Yes, this is false
Yes.
statement. It is perpendicular. It is not perpendicular to itself. It is parallel to itself. Okay. So L1 is not perpendicular to L1 itself. That means R is not reflexive. Now, if L1 perpendicular to L2, then it is obvious that L2 is perpendicular to L1 because this is perpendicular. Then this is L1 and this is L2. Then L2 is perpendicular to L1. So L1 comma L2 belongs to R. That implies L2 comma L1 belongs to R. So R is symmetric. Okay. Now check whether R is transitive or not. Now I am taking L1, L2 and L3. These two elements. L1 comma L2 belongs to R and L2 comma L3 belongs to R. L1 comma L3, is this belongs to R or not? Check. Now what is
Yes.
yes, no, actually we can construct such L1, L2 and L2, L3 such that L1 and L3 are not perpendicular. I mean, in common sense, we think about that if L1 perpendicular to L2 and L2 perpendicular to L3, then L1, L2 are also perpendicular. But we cannot this is not true actually, because suppose this is L1 and this is L2. Okay, now okay, now this is L3 and this is one scenario, and this is, suppose this is L1 and this is L2. Okay, this is L3. This is one scenario and this is second scenario. See that L1 is perpendicular to L2 and L2 is perpendicular to L3. I mean, both L1 L2 belongs to R and L2 L3 belongs to R, but L1 L2 are parallel. Can you see? These two are parallel. Here also same thing. This is L1 and this is L3. These two are parallel, whether L1 and L2 both are perpendicular with L2, right? So it is not a
Yes.
transitive relation. Okay, but
Okay.
but 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 if we take L to be the set of all straight lines on xy plane and define R such that L1 comma L2 such that L1 parallel to L2, L1 L2 belongs to L, then R is a reflexive, symmetric, and also transitive relation. Because from the above example, you can easily check that L1 L2 is, if these two are parallel, then L1 is also parallel, and this is reflexive because a straight line is parallel to itself. And if any three is parallel, I mean L1 is parallel to L2 and L2 is parallel to L3, then L1 and L3 must be parallel, have to be parallel. Okay, Praditi, did you get it?
Yes.
Sure.
Yes. Sure.
Okay, both of them, both of the examples. Now I am defining a relation on the set of natural numbers. Now this is R is defined such that A comma B such that A B minus A is even. A B A comma B belongs to N. Check whether R is reflexive, symmetric, or transitive. Okay. Okay. Tell me, is R reflexive? What about A minus A? Because we have to check A comma A for all A. Remember this. So we are checking for all A. That is why we are taking an arbitrary element A from the natural number N. Right? We are not specifying some element that this we are taking this element, this element. We are taking in general some element from natural number N. A is a number which is natural, and we are looking at A minus A. What is A minus A? This is 0, and 2 divides 0, right? Hello.
Yes.
So R is reflexive. Okay. Praditi, did you understand?
R can be symmetric also.
What?
R can be symmetric also.
R, not I. What are you talking?
R.
Yes, yes. R is symmetric also. R is symmetric. Okay. Because if A minus B 2 divides A minus B, then also 2 divides B minus A. Okay. Now is R transitive? So what are we checking? we are checking that 2 divides a minus b and 2 divides b minus c. So this implies that 2k1 equal to a minus b, and this implies that 2k2 equal to b minus c. Now we have to check whether a minus c is divisible by 2 or not. So we are bringing b as a mediator. So this is a minus b and plus b minus c. So a minus b is 2k1 and b minus c is 2k2. Combining these two, 2k1 plus k2 and 2k3. And all k1, k2, k3 belongs to z. Remember that. Z means set of all integers. So 2 divides a minus c, and hence R is transitive. Okay, but this is not a antisymmetric relation, because if relation is antisymmetric, it is clear that, note, if R is symmetric, then it is not antisymmetric. This is obvious. If it is antisymmetric, then it is not symmetric, vice versa, and this is obvious from the definition. So R is transitive, R is symmetric, R is reflexive also. This kind of relation, which is reflexive, symmetric and transitive, then R is called an equivalence relation. So if you are asked to check whether a relation is equivalent or not, or equivalence relation or not, then you have to check whether R is reflexive, symmetric and transitive. If R is these three relation, satisfies all the condition of these three relation, I mean R is reflexive and R is symmetric and R is transitive, then R is called equivalence relation. Okay,
Okay.
so uh, that is for today. Okay, I will continue again the next day. Okay.
Okay.